We have another method to calculate the angular velocity. That's called relative motion method. We calculated the angular velocity by using the ground frame method. Theta we have taken as the angular displacement or angular position of any straight line drawn inside the rigid body with respect to a fixed straight line, and we have seen in which way that theta is changing. If you know the variation of that theta, that angle with respect to time, take the derivative of that angle. At what rate that angle is changing, you can calculate by taking the derivative of that angle, or differentiation of that angle gives you the angular velocity. That's the ground frame method. This method is based upon the relative motion. A relative motion method also you can calculate omega, and the theory behind it is a relative angular velocity. This is the concept. Let us discuss this concept now. Relative angular velocity. Relative angular velocity. You take a point, you take another point. This point moves with some velocity, this point may move with some velocity, point 1 and point 2. Point 1 moves with velocity v1 say, point 2 moves with velocity v2 say. The line joining these 2 points has distance L, distance of separation. This angle, it will be theta 1, this angle is theta 2. Along the line of separation, this is called line of separation. You resolve the velocities. This is v1 cos theta 1. Resolve the other velocity along the line of separation. This is v2 cos theta 2. So v1 cos theta 1 plus v2 cos theta 2. This is called velocity of approach. This physically means that when you stand on this point or this particle, if you stand on this object or particle, point object or point mass, if you stand here, it seems as if this point 2 is approaching towards you, moving towards you with a velocity v1 cos theta 1 plus v2 cos theta 2. This is one component of its velocity, and the component of its velocity along the line of separation towards you is called velocity of approach. In this particular case, when you stand on this particle number 2, this particle seems to approach towards you with same speed. However, this is not the total velocity of this particle with respect to you. This is the component of the velocity of 1 with respect to 2 along the line of separation. That is called also velocity of approach. This is approach velocity, this is also approach velocity. But these two velocities are equal and opposite. The velocity with which each particle seems to move towards each other is called approach velocity. Well, let us now take the projection or component of their velocities perpendicular to the line of separation. V1 component perpendicular to the line of separation will be V1 sin theta 1. The other velocity V2, its component normal to the line of separation is V2 sin theta 2. Let us analyze it physically. You stand on this particle. 1, this particle seems to turn around you with a velocity V1 sin theta 1 plus V2 sin theta 2 in this sense. If you stand on this particle 2, you can say that particle 1 turns around you or about you with the same speed sin theta 1 V1 sin theta 1 plus V2 sin theta 2. So, this is called turning. One turns around 2. Here the 2 turns around 1. Turning, that's very important concept, turning of a particle. Turning was you can use, turning word you can use for a point mass or for a particle or for a point. However, the rotation word you cannot use for a point. Point 1 is turning around point 2. Point 2 is turning around point 1 with same angular velocity. And that angular velocity is called relative angular velocity. And that is given as omega to 1. Angular velocity of 1 with respect to 2, that is given as omega 1 2. Angular velocity of 2 with respect to 1, that is given as omega 2 1. Angular velocity of 1 with respect to 2 or 2 with respect to 1, they are exactly equal. I am going to prove it. Whereas linear velocity of 1 with respect to 2 perpendicular to the line of separation, linear velocity of 2 with respect to 1 are equal in magnitude but oppositely directed. So, V12 is perpendicular component, and if you intermix these two effects, they are approaching at the same time, they are turning with respect to the other. Combiningly, the particles 1 and 2 are approaching towards each other and simultaneously they are turning. That is the concept, central concept. Turning, they are turning around or about or with respect to each other. With what angular velocity they are turning? When a particle turns with respect to or relative to or around or about another particle, another point, we can have a non-zero angular velocity. That is what I am going to tell you now.